Please help me in welcoming to the stage Professor Pattie Maes. I love this music. This is such rock star music. This is great. Go get them.
American woman, stay away from me.
Good afternoon, and thank you for sticking around for the closing keynote. So I run a lab just a couple miles away from here at the MIT Media Laboratory, where we try to think big and dream big about human-computer interaction. We try to radically rethink how people relate to their digital devices. And in this work, we're inspired by this quote from Steve Jobs, who is almost like a god of human-computer interaction to us. What a computer is to me, it's the most remarkable tool that we've ever come up with, and it's the equivalent of a bicycle for our minds. So we try to build better bicycles for the mind in my lab, but I would like to ask the audience here, if you had to sort of gauge or how good these mind bicycles that we use every day, that we're all like tethered to almost these days, how good are these mind bicycles today? Are they closer to the bike of the 1860s, the high wheel or penny farthing bicycle? Or would you say that they're closer to the one on the right, a 2019 speed racing bike that is completely integrated with the rider, allows him or her to go 35 miles an hour as opposed to 15 miles an hour, and of course with a lot less of a chance of having some accidents? Well, I think we're still in the era on the left, actually, when it comes to digital devices. There's a lot of improvement that can be made. Devices today, of course, put the world's information at our fingertips, which is absolutely wonderful. However, their use is extremely disruptive and inefficient. They require our complete attention. We have to shift from looking at the machinery around us, the stuff that we're dealing with, the people that are around us, to this little device to be able to make use of it. The information that they present to us is not integrated into the world, so we constantly have to make the connection between what we see on the little screen and what that means in terms of the stuff that is around us and that we're dealing with. Their use is not hands-free, except if maybe you use limited speech input-output. So we can be doing something else while we're actually using the device. The display is extremely small, doesn't make good use of our full sort of field of vision. The devices only use visual and occasionally auditory modality to give us information, and in terms of input, we're limited these days to using 2 thumbs to tell the device what we want, or maybe speech. So this input-output, this bandwidth, is not at all sufficient for really providing this integrated experience that maybe would be the equivalent of the speed racing bike of 2019. In addition, today's devices only give us access to information, but there's a lot more that people need to perform well and to do well in whatever, and to accomplish their goals. They need to be able to be attentive. They need motivation. They need to be able to make smarter decisions, develop better habits, learn over time, be creative. They need to be able to control their emotions, and so on. All of these are arguably equally important to having access to information to do well in your job or in life. And today's devices actually don't not help us with this, but they actually have a detrimental effect on all of these functions. There's study after study is coming out these days, now that we have smartphones in the hands of a third of the Earth's population, basically. Study after study is showing what the effects are of smartphone use on our cognitive abilities. Our memory is weakened, our ability to be creative is lessened, we are less effective at solving problems, etc. Just having a phone nearby in your visual field, upside down on a table, makes a person less good at solving problems than not having a phone there. So without even using it, just the presence of that phone makes a person less able to perform problem solving. So in my lab at MIT, we've been asking this question for a while now of how we can create minimally disruptive devices that support optimal performance, optimal functioning. And what I'll do today is give you some examples of systems that we've been building. I believe in all of these systems that we've been building, you'll see sort of 3 technologies used over and over again to really redefine how we interact with devices. And I think that these 3 technologies will really make a huge difference in bringing us from the high-wheel mine bicycle to the racing bike. The first technology is that of new display devices that can integrate information that the system presents to us in our perception of the environment. Of course, here at the conference, you already saw a lot of examples of visual augmented reality, and surely, slowly but surely, the AR devices are making progress and are getting better and better and are becoming more and more usable, definitely in an industry context. There are devices like the new Microsoft HoloLens, the new Google Glass edition that just came out. Some of you may have seen the Focals by North on the left here, which look exactly like a pair of regular glasses, but can give you real-time messages without sort of taking you out of your environment. But in addition to visual augmented reality, I think we'll start seeing more and more use of our other modalities to give us information. So audio-based augmented reality in combination with speech input will become increasingly important. We've been working, for example, in my lab with Bose in developing these audio AR frames, a pair of glasses that actually can, based on where you are, where your head is turned, etc., can give you information in auditory form without blocking your regular hearing. We've also in the lab been working on other modalities like haptic input to the body or scent-based displays. There's a huge opportunity for using scent as a way to convey information, to calm a person down, etc. And I'll show some of that work a little bit later in my talk. So this is the first technology, and here's just one example. I'm sure this audience has seen enough relevant examples. This is Google Lens, which does real-time translation so that you can be in another country, wherever. That might be Russian, I don't even know. But you don't even need to know what language it is because the system can in real time translate all the signs that are in front of you so that you see the world in English, the signs in English, while someone else sees them in whatever the language is, Russian, I think. Second technology, sensors. Today's devices are mostly blind. They don't know what it is that we're doing. They know very little about our context, the fact that you're listening to a talk or that somebody is in a meeting, etc. They also know very little about the person. Is the person excited right now? Is the person a little sleepy right now, etc.? in the near-term future, I think we'll see devices adopt more and more sensors, not just to make sense of the context of the user, what is around the user and what are they doing, what work are they involved in, etc., but also sensors to sense the user, the internal state of the user. You'll see examples in our work, a lot of examples that make use of EEG, for example, so brainwave activity, based on sensors that these days can look like a pair of glasses. You can now know whether a person is attentive or not, is paying attention or not at the moment. You can know whether they're sleepy or not, and so on. There are sensors like the Empatica E4 that give you electrodermal activity, heart rate variability, etc., that are an indication of how anxious a person may be at the moment, and so on. And in combination with AI technology, in combination with AI technology, these sensors, the information that they can collect, can now be analyzed in real time. There are programs like YOLO on the right there, which is an AI-trained, a deep machine learning network or model that can recognize in real time objects around the user, a banana, a bowl, etc. That model, that neural net model, can actually run on a cell phone today and do real-time recognition of objects. Similarly, there are models that can recognize audio in real time. There are free models available that can recognize dog barks and sirens and all sorts of other sounds, sounds of a person talking, etc., that can be used by a system to make sense of what a person is currently facing, what the person is currently dealing with, and then, of course, respond in different ways based on the situation. The third technology, of course, that will radically change how we interact with devices is artificial intelligence. I already mentioned that it will be used to analyze all that data about the context and the internal state of the user, but it will also be used to issue interventions, to decide proactively what information to present to a user in real time to help that user with whatever problem they're dealing with or whatever situation they're dealing with. So the system will recognize the context and then issue an intervention to try to optimize the performance of the user. Let me give you some examples. These integrated devices will offer, these devices that are more integrated really with the user, will offer opportunities for people to be making better decisions, be more attentive, learn in real time, be more creative, take better control of their emotions, and more. Take decision making. This is work from my former student, Valentin Heun, who's now actually at PTC running an advanced R&D lab. So this system gives you visual augmented reality, helping you make decisions, say in a supermarket, but it could be an industrial context as well, based on your personal needs, your personal allergies that you may have to certain cereals, etc. So Valentin did a lot of the work on sort of visual augmented reality in my lab, and I'm pleased to announce that he's now running this advanced R&D lab with several other of the students that I worked with at the Media Lab, 4 of them in the picture there, and you may have seen some of the demonstrations here in the exhibits hall that they've been working on. But don't just work on visual augmented reality. A lot of the work that we've been doing is on sort of augmenting other parts of our perception. This is some work that my student Guillermo Bernal has been doing with E&I, an Italian company, in building a smart jacket and a whole smart outfit, actually, for workers that detects all sorts of data about, say, gases that may be present in the environment, the altitude of the person, temperature, heart rate, breathing rate of the person, position or movement of the person, etc. And the system has some intelligence built in so that if the gas sensor, for example, detects some exposure that the person may not even be aware of, it gives a haptic feedback to the user and tells them to put on their gas mask. Or the shoes that were developed can sense whether the person is picking up some object that is too heavy, as you'll see in the video, and will then basically alert a nearby worker, asking that nearby worker to come and help the person with lifting this heavy object. So this whole team of people, workmen, is basically augmented by an AI system that can keep track of the safety issues, especially related to their job, and can in real time issue interventions, remind them to do things, ask a nearby person to come help someone, etc. Of course, apart from monitoring performance of these workers, this type of sort of monitoring and data gathering in real time can be used to identify and share best practices at the workplace, understand team performance, and can help the company gain new insights about work processes, where mistakes are made, etc. In some other work that we're doing at the lab, we're trying to go a step further, and we thought, well, what if you could just ask a question, a verbal question, but it's sort of internally in your mind, and get the answer as if it's coming from your own mind. So we've been working on a silent speech interface, which is actually not a new concept, and there's been a lot of work on at NASA as well in this area. The system picks up information that you still send to your speech system when you silently speak, but deliberately speak a question without actually moving your mouth or making real sounds. And so it picks up this information from electrodes. We trained a neural net to basically recognize phrases that the person sends or says to themselves internally, so that you can just, for example, connect to IoT devices and operate them just by silently speaking the commands, or you can silently issue a message or ask Google what the weather will be like tomorrow, etc.
What is 45,689 divided by 67?
Sure.
He silently asks the computer and then hears the answer through vibrations transmitted through his skull and into his inner ear.
6, 8, 1.9, 2, 5.
Exactly right.
One more. What's the largest city in Bulgaria, and what is the population?
The screen shows how long it takes the computer to read the words that he's saying to himself.
Sofia, 1.21 million.
That is correct. You just Googled that.
I did.
You could be an expert in any subject. You have the entire internet in your head.
That's the idea.
So we at the moment have a 90% accuracy rate, but that is when the person is still. So when they're moving, it becomes a lot more complicated to do this. but we are making steady progress on making this new type of basically verbal voice-based, without a voice, interface available to people so that they can more seamlessly and more quickly again look up some information, access a service, etc., without having to take their phone out or say a command out loud where everybody else around you has to listen to what you're saying. We're also working on issues like attention. I believe that this is actually one of the areas that devices can help us with and that would make a big difference. We have been building glasses that can pick up brainwave activity as well as your eye movements, EEG as well as EOG. And we use that to train a system again to recognize what a person is paying attention to and whether they are paying attention. So here, for example, this is an older version of the system, but we used the system in a classroom context and gave people who were listening to a speaker, just like all of you, some real-time feedback every time their attention was waning and they stopped listening to the person in front of the room. And on the right, you can see the results of quizzes, tests that we gave to people after about the material that the speaker presented. And you can see in blue, this is for 3 different studies that we did. The blue one is actually, the blue bar is the people that got biofeedback every time they were less attentive. The system said beep, or would tap them on the shoulder with a haptic device, telling them to be attentive again. In gray, you see the people who got random feedback, and that helps as well, actually. And then in orange is the performance of the people who did not get any interventions, basically, to help them pay attention. We've used this system in a variety of contexts, not just learning contexts, to show that this significantly improves the attention level of the people wearing it. But we've also used it in work contexts. For example, people doing programming and other type of desk-based work who would wear the device all day long, and we've monitored their performance, how they did. We've also used it in a car driving simulator that Mercedes-Benz donated to the lab. You see on the left here the person trying the driving simulator for an hour late at night. And again, the people who use the device actually do a lot better in terms of paying attention to the road than the people who were not getting the biofeedback. What is interesting also about these types of systems is that they can intervene like this, again, giving you a little message or some haptic feedback when you need to be more attentive. But they can also learn whether that intervention was effective, because the system can, of course, learn whether your attention level, or notice whether your attention level picks up after it intervenes or whether it remains low. And so these systems can even learn over time. For example, when the user habituates to the feedback, they can shift to another modality or another sound, another type of feedback to remain effective at guiding the person's attention back to the task at hand. Learning is another area that we've done a lot of work on. Of course, today, kids still go to school for many, many years and then are supposed to enter the workforce and sort of just perform. But increasingly, of course, learning will happen based on current needs, based on what you want to learn. I don't need to be able to repair or diagnose and repair my car unless my car breaks down somewhere and there's no people around that can help me in the vicinity, in which case I could maybe put on some AR glasses and learn how to fix the car myself. Increasingly, I think that all learning, all training will happen this way based on needs. And of course, the learning and the information presented can be completely personalized so that the information presented is relevant to whatever I already know and so on. My device and all of your devices have the potential to know you better than your spouse, your parents, your best friend. Your device is with you all the time and can know what information, what situations you've encountered already, what information you've absorbed already, etc. And the device has the potential to tailor any new information to whatever it is that you already know or don't know. So another group member who's now at PTC has done a lot of work in this area of personalized learning with AR and VR devices, Christian Vasquez. And he used the HoloLens, for example, to help a person learn another language by just having them walk around their regular home and so on, and having everything around them labeled in the language that they want to learn. You can see examples.
Please give me a cup of milk.
So when you encounter a new object, you don't know what it's called, you can get example sentences, etc. Christian also developed another application where you would learn words as you performed an action. And we tested whether, like swing left, swing right. This would have been good for the Game of Thrones people that were here yesterday, but it looks like it comes straight out of one of their movies. But basically, you learn words as you are performing the actions. And what Christian showed in his thesis work before he came to join PTC is that basically, when you learn information this way, when you are involved in the action, you actually retain the information a lot better. So not only are you more engaged, and is it more fun to learn this way in your real world while you're performing actions, but we tested with a controlled study and showed that people forget things less quickly when they learn in context like this and while they are performing physical actions. Of course, it's not always an AI system that, say, labels your world or tells you about your world. We've also done a lot of work on making it easier for remote people to actually teach someone how to do something. So this is work that we did now almost 6 years ago, but it's still not commercially or commercialized, but has a lot of potential. This person here is trying to learn how to use the laser cutter, and he can call up a remote expert, this lady here, and she can make her hands show up in his visual field while she talks to him. So she can say, no, it's this button, no, and this slider needs to be about over there, etc. So we actually pick up the position of her hands in real time and show it in the remote user's visual field using AR so that that remote expert can actually show what to do and can guide someone through a very physical type of task. We've even gone beyond that a little bit, and this is actually work from a colleague, Reki Motto, but we've done some work along these lines as well, where we pick up movements of one remote person using electrical muscle sensing, and we control the movements of another person's hand by stimulating their muscles electrically in the same way so that you can transfer motor learning from one to another person. So this is, again, a device that one of my students, Guillermo, worked on, where he's trying to transfer knowledge from one expert in clay and wheel-based pottery to another, to a novice, basically. And the system is in real time stimulating the hand of this novice based on the data from the expert, so that this novice can learn what it feels like and how much pressure exactly they have to exert to make that thing not swing off the wheel as so often happens. Creativity. We will need a lot of help, I think, with being more creative and more inventive. And again, Guillermo in my group has been working on an AI-based assistant that helps you during the creative process. So he basically built a drawing system that recognizes what it is that you're trying to draw. And that can be, for example, a volcano in this case. And then it gives you other things that it can add to that image that are related to the concept of a volcano in this case. It can also color in the volcano, complete a picture for you, embellish it, etc. But it can also add other elements that can be added to the picture that go with the concept of a volcano. You can do a text-based search to come up with examples of drawings that basically can be used in your picture and more. So this system really makes it easier for somebody to be creative, to express themselves visually or artistically by giving them this real-time assistance. And the good thing is that we are now working on sort of updating the databases of sketches so that every time somebody makes a sketch, we add that to our big database of sketches, and the neural network algorithms interpret that data, etc., and can then make them available to new people when they are sketching something, so that as this system is used by more and more people, it gets better and better because you can benefit from the visual, the artistic expression capabilities of all the people that use this system. Of course, instead of just making pretty pictures, this could be creating models in a particular domain. We are working with one company at the Media Lab that is doing this in the area of molecules and designing molecules for targets or for drugs that could be tested. Emotion regulation, another function, cognitive function that it would be great if our devices could help us with it. Judith Amores in my group has been looking specifically at scent and how scent can be used to calm people down when they are anxious or nervous or stressed. And she built this scent device that can release scents in real time based on heart rate variability, based on your EEG, brainwave activity, and more. She's published several papers that show that this device can actually train a person to calm themselves down when a certain scent is produced, like vanilla, for example. And then that same scent can be used without VR in real life. When the person is anxious, the system will recognize this based on the heart rate, based on the EDA, the electrodermal activity of the person, and will release that same scent that the person associates with calming themselves down, thereby helping them with this particular sort of emotional control task. Similarly, the person could associate a different scent, say peppermint, with being alert. That, again, the system could recognize when the person is not very attentive or alert and could then produce the peppermint smell to make the person more alert. So the nice thing about this type of interface is that it's using a modality that is not at all in use right now in a work context, and that nevertheless can really convey information, can have an effect in terms of the behavior of the person.
Everything starts by measuring the physiological...
Sorry, I'll just say before this starts, we did a collaboration with Audi where we put some of these technologies together to see how it could be used in a car.
Everything starts by measuring the physiological signals of the driver. Here are some examples. Sensors on the door handle or steering wheel of the car can detect forceful grasping, which is usually associated with stress. Heart rate and respiration can be measured remotely using software we have developed. We have incorporated existing biosensors into the steering wheel to directly measure stress indicators such as increased palm sweat. We have successfully validated this type of sensor in other real-life settings and demonstrated this is possible. Finally, gathering voice features such as pitch and volume, as well as measuring touch interactions with the GPS, we can provide indications of stress. Once emotional information is measured, the car can tune its behavior. Under extreme stress, it's common to experience tunnel vision, which may negatively affect our awareness. The car could compensate for this by increasing the field of view of the headlights. If the car detects the driver is overly stressed, it may recommend listening to relaxing music or to reduce the temperature inside the car. If the driver is too calm or tired, a more active song may be suggested. The voice of the GPS could also be modified to mirror the emotional state of the driver and build empathy. To combat stress, information can be provided to the driver so he or she can take control of the situation before it's too late. We built Automotive to display the stress levels through a subtle color change on the dashboard. The same type of information can also be provided to other drivers to improve driving safety. We built a prototype showing that thermochromatic paint could be used to change the color of the car, indicating that it may be better to keep a larger separation. We could also make predictions about the future stress levels of drivers and appropriately tune the car to face challenging situations ahead. Aggregating stress levels of hundreds of drivers around the city, we could find the most stressful areas. This information could help design better cities and maximize the well-being of its citizens.
I'll stop it there. I hope that these examples from our lab gave you a more concrete sort of vision of what we're trying to do. We believe that next generation digital devices will really integrate a lot more with people to really seamlessly support not just their information needs, but all of their cognitive needs, all of their cognitive function, attention, motivation, memory, creativity, and more, so that they can optimally perform. Of course, I want to end with a very important reminder that the ethical sort of considerations of all of this work, that we take those very seriously, and that these are extremely important if we consider putting these devices into the real world. One is, of course, protecting the user's privacy, given that all of our devices are collecting a lot of information about the user, their brainwave activity, when they're active and not active, and stressed and more. It is extremely important that that data remains private. We do that by trying to build local implementations that are not networked as much as possible. For example, the attention glasses are not networked, so that data about how attentive attentive the person is during my talk, say, is not shared with others. Second, users should, of course, be in complete control and should choose voluntarily to be augmented, to be monitored and augmented like this. This should not be imposed on them, in my opinion. Users should also have complete understanding about what information is being gathered and how that information is being used, so there should be transparency in the data and the software that is used. And last, in all of our work, we try to avoid dependency whenever possible. So whenever possible, we try to teach people how to do something by using these devices rather than making them dependent on the device. For example, the attention glasses, our hope is that if people use the attention glasses for long periods of time, this will actually increase their natural ability to be attentive so that they need the devices less. So I will end there. Thank you very much and have a good trip home.